So friends, we are going to accelerate the Python code for Opencv and pytorch, and we are going to test it. So how to do that I will tell you. So we are going to install the latest version of the Python 3.7 would be better, I think, or 8. Okay, 3.7 Linux download. You go to the Python. So let us make a terminal installation. We don't want to go with the Debian one. Okay, so Linux terminal install. Okay, and just click this. So it would be better, you can even go with 3.8. okay, that's not a problem. By downloading it manually also you can do it, but we can go with this. So install the Python. So Ubuntu update, build essentials, all those things. So what about 3.8? I guess, because what we are going to do now is a new one, that we are going to compile Opencv for cuda and everything. So now what we have to do is we have to install the Python and we have to compile Opencv for cuda. So what happens here is this is 4.5, and what kind of Python they use is, let me show you. So it's about C. So we need a Python executables and shared libs. If you want shared libs, Python executable on virtual environments. So it is to be activated on the virtual environments. Okay, this is the correct one. So we have to install Python now. So let me go with this. Okay, installing Python 3.7 on terminal. Okay, so let's go here, install Python 3.7 Ubuntu. Okay, so let's get down, and it's just sudo apt get install or sudo install, it depends on that. Okay, so installing it from source would be a different concept. Okay, so let's install properly. Okay, let's take some thing. So it's all error, you have about error. So new fewer pythons. Okay, so these are the 3 commands, main commands, what we are going to do. So let's get started. Okay, sudo apt kernel, these are all not needed, so we can go with sudo apt update. Okay, copy this, take it over here, paste it. Okay, I have given the password and it's running. So install software app properties. So the next command would be this. Okay, right, and the third command would be this. So I will give you the website for installing it, so you don't have to worry. So just click enter. Okay, so now there is a deal here. So we have to go with 3.7 or 3.8. It is better to go with 3.7. There is no nothing wrong with that. Okay, and just type Y. And we are done with the installation, I guess. Okay, so Python 3.7 is being installed. So before that, I have to tell you about 2 more things about this cuda and installation. So see, we have just made a video on this, you can go and watch it. It will be posted before this. Okay, so what happens is that you just type Python, and I think we have to restart the system. Okay, Python not found. So for it is apt get or apt install, so you have to run okay, Python 3 install, Python 3, so it's installed 3.6.9 and Python 3.7. So both are being installed, so we just have to tell the numbers. Okay, right, so far so good. So we have done with it. So the next one would be we are going to compile it for cuda. So first let update it. Okay, please don't be confused that this is 20.04 and we are installing it in 18.04. There is a reason for that. Before that, I'll show you something. Okay, you just type nvidia-smi, which would tell you what kind of GPU we have. We have about RTX 5016 GB GPU, a really costly one. This session was given by our mysterious friend who was very kind enough to do this. And the CUDA version 11 is being installed, and I will also show you that. NVCC VERSION. So this is the NVCC CUDA version. So far so good. So we have installed Python 3.6. So now what we are going to do is we are going to update it first. Okay, when we are doing this, we are going to make a virtual environment. Okay, and what we are going to do is we are going to accelerate the code through that. You will understand this within a minute. Okay, installing Opencv externally is different from installing Opencv internally. Okay, I'll tell you what is that. This is the correct procedure of doing it. This is an industrial grade method of doing. Okay, okay, it's done, it's upgraded. Then you have to go for this. I'll surely give you this website. I'll also make a note on it. Okay, let's just paste it, and you just have to go through all these things. There is nothing more than that. Okay, I'm just copying the website ad. Right, so I guess we have finished this, I guess. Let's see. So let's uplift it and see. It has already been done. Yes, it has already been done. And you have to install this. You just neglect the dollar symbol. Just do what I am doing now, because this could take a time. Okay, so these are all needed libraries and installations that you have to do. Okay, and the next one would be this. Okay, for the next one would be this. Then paste it. Y, just click Y. And the second one would be this. Okay, right. So what happens is that we will make a virtual environment separately, and we are going to install the pytorch GPU and Opencv GPU on that, and we are going to check it and see. Okay, okay, right, it's done. Okay, so it's dev kind of these things. Okay, so we are at the third stage. Okay, don't miss anything in this line. Okay, you don't confuse, because we are in CUDA 11. You don't have to confuse with 11.2. okay, because it is equivalent, no problem with that. Up to CUDA 11.3 also you can do. Okay, and the third thing would be this. Okay, Okay, right. Okay, and the fourth thing would be this. You have to, so everything has a reason. Don't use any commands without knowing it, because it could result in very damage. It could damage your system. Okay, it could really damage your system. So without knowing, please don't use it. And these interfaces for cameras and programming we need, so we are going to install all these things. Okay, so these are interfaces libs for video.h, so not needed for now. Okay, so it is a GTK graphical user library for Opencv. It will be better, so we will install this. These are for another purpose. Okay, even though we will install the first known thing, which would be great. Okay, that's not needed. Okay, so what I am telling you is that the main thing is that you can neglect this. Okay, and now what happened is that Python development pip, now you have to install this Python 3 for pip and all those things. Okay, okay, pip, Python 3 pip. Okay, why? Right, and you, of course, you have to upgrade it. Okay, with pip 3 install numpy. Okay, and just paste it. And the third thing would be the sudo apt install Python 3 test resources. Okay, just install this as if it is given. Okay, right, and this is for parallelism, C++ for CPU, so you don't have to confuse with this GPU. Okay, I will tell you all those details now. Okay, paste this and click Y. Okay, and this is gfrotron. This is for optimization of these libraries for a specific purpose. Okay, you just have to install this. Okay, Y, right. Now these are all optional libraries, but it will be better that you install it. Okay, these are all optional libraries, but it will be better you install it. You just copy and install it. Okay, and you just copy this. And copy this, paste it, just install it. So never miss anything. Okay, so we have done with these things. We have even installed the optional libraries. And CD downloads, we have to go to the downloads and we have to download all those things. Okay, this 4.5.2 zip. Okay, on Opencv archive you can also download it directly. Okay, right, it will take some time. Okay, right, and this also will take some time. Okay, right, it has been downloaded. Now we have to unzip these both things and there should be a folder called build up inside it. Okay, unzip it. And the another one would be contrib, so we have to unzip this also. So both are 4.5. Okay, both are 4.5, and you have to unzip it. Okay, now what happens is that we are going to create an virtual environment. Okay, a virtual environment, and this is what we are going to do. So let's install a virtual environment. Sudo pip install and virtual wrapper. So we can just paste this. Sudo install virtual wrapper. Okay, so it will take some time. Wait a minute. Okay, now what you have to do is you have to run this in order to clear the cache. Okay, because there will be some cache memory available there. So you just paste it and echo edit bash rc, and you have to export all these things. Virtual environment. Okay, you have to echo edit bash rc. Okay, edit bash rc. So echo edit bash rc and export these virtual environments would be better. So in order to do that, the only way you can do is you can copy this thing, user bin python 3. So you just copy this thing. First you echo it and you just do a gedit, so both will be better. So first what you do is you export it. Okay, and it will be only recognized only for a few minutes. So now what we have to do is we have to also uh, save it in the bash rc. So in order to do that, what we have to do is we have to go to the gedit and bashrc. Okay, gedit bash rc. We are wrong. Okay, wait a minute. Gedit bash rc. So this dot has to be here, because or else you will get wrong. Okay, gedit bash rc. And now what you have to do is you are going to copy this virtual environment. Okay, get over here, go down this, just paste this, and again you come here and you go down here. Okay, and paste this. Okay, and save this, close this. Okay, and get back here and just type source bashrc. Okay, so far no error. So now what you have to do is you have to source the virtual wrapper, or else you can also save that in the thing. Okay, source virtual wrapper .sh, what we have given. Okay, so I think we can also save it in the bash rc, I guess. Right, control V, and we can source it. So you can just source bash rc. Okay, right. Now what you have to do is you have to make a virtual environment called cv. Make a virtual environment called cv and copy this. I will tell you again. So what are all in the gedit bash rc, I will tell you. So what are all in the gedit bash rc? These are all old cuda environmental libraries, and these are the new ones. Okay, so in here what we have done is we have made a virtual environment. We have to make a thing called workon cv, and we have to create these things. Okay, take a very good look at it. Thank you. And now what you have to do is you have to make a virtual environment in the name of cv. So the cv name is given over here. Okay, so just click enter. Okay, you have done with workon cv. So now what happens is that There is a folder named CV, I guess. Okay, in the home, I guess there is a folder named cmake.sh, not this thing. Maybe in the side packages. It is in the side packages, not over here. Okay, so it may be in the side packages. So we are running it on CV. Okay, so you can now test it by installing Numpy. Okay, now you don't have Numpy in this environment. For example, I will show you. So you just type Python and you just import Numpy. You just type import Numpy and there is no module find over there. So what you do is you just install this Numpy now. Now it is a fresh environment. Okay, now it is getting installed. Okay, now if you type Python and you just type import Numpy, it will be a fresh environment and it will recognize it. Okay, now we are in here, and now what we have to do is in downloads we have to get to the CV Opencv 4.5.2. okay, we have to get there and we have to make a directory. Okay, paste this cd Opencv 4.5.2 and we have to make directory build inside it. So we are building it building a directory. Okay, and the another thing would be cd build, getting inside the cd build. So I will be explaining you on the cmake. This is very crucial one because if you don't understand it you may get a lot of error. Okay, now what they are telling you is that there is a virtual environment in the bin python library which is given over here, where you go to these other locations and you go to the computer, and in the computer if you go to the side packages everything will be available there. So in the libraries and in the side packages everything will be available, so we are not going to go there. So first thing is that we have to enable the cuda. Okay, and there are lots of packages for Opencv making an executable. So these are all things are available. So now what we have to do is we have to copy this thing. Okay, copy this thing. So the main thing is that cuda should be enabled on. Okay, so we have to get here and then just paste it. So make a note that it is cmake. Okay, now what if you have so far done it correctly and if there is no error, this should compile correctly. Okay, so let's see. Okay, so far so good, there is no error now. Okay, so these are all architecture details about what kind of 7.5 arc bin, all those are architecture details. So we have 75, GPU arc is 75 because we have nearly RTX 5000, so it will be nearly 75. So far no problem has arisen. Okay, so we have to make this sudo make install and everything, and we have to run the configuration. Let me show you. So just wait. So this will take a very long time, so you have to stay with us. Okay, it's almost done. Okay, it's almost done, and it is telling that the configurations are done and everything is done. So far it is good. So you can, this is all details, so we don't need to go through these things. So we can go for this nproc and just install it nproc. Okay, it is 32, maybe returning the SM architecture or something. Okay, it is returning the course, number of course. Okay, number of course. So we are going to make an make J8. We are going to make use of the 8 cores. J8 is nothing but 8 cores. So we are going to make it. So here it runs. So it will take a very long time to finish this because lots of stitching and all those things are involved. So before that, I will tell you that you have to sudo make install it also. So be very careful. There should be no error during this process. If there is error, then I am sorry that you have to repeat all those things. Okay, so bear with us. So wait with us. Okay, so it has about 41%. It has completed so far, no error. So we are going confidently. So let's wait and see. So it's about 62% and it's going good, so we have to wait. So it will take a very long time, so I'm just showing you the just in between, so you have to be very careful. Some errors are showing up, but it's not just a warning, I guess. So I hope no error shows up. So it has compiled 97%, so we have to wait. And the next foremost thing would be we have to um, run this after CMake. I think we have finished the CMake. Okay, so these are all for checking. So the main thing would be okay, the main thing would be uh, after this you have to run this sudo make install, and after that you have to run this. So we will do it step by step. Okay, okay, it is actually right. I think there is no error, I guess. Okay, it is just building it. So far it is only showing warning. Okay, okay, it's done, I guess. So it is just now what it is doing is it is just compiling up to 100%. It has to finish automatically, so we have to wait. So let's wait and see. Now what happened is it has been done. So now you have to run this command sudo make install. Okay, so this is the most vital one. So you have to run this. So every configuration is done so far. Okay, it is just compiling it again, so it will be over as soon as possible. So just wait. Okay, it's done. So sudo make install is also finished. So we have also sudo make installed it. So now you should include the libraries in the package. So you have to run this command. This is must. So just paste it, and again sudo ld config should be there. So okay, so ld config, right. So the other thing is that they are telling you that in the virtual environments, in the CV site packages, so you can't see that actually when you go here, no, you can't see that. When you click Control H, you will be able to see this virtual environments. You can see here. Okay, so CV is over here. Okay, now what you have to do is you have to copy the .so into this site packages. Okay, how I did this is you have to type Control H. Okay, you have to type Control H and you have to get here. Okay, this is what they are doing. So they are telling you to change these packages config and all those things, that those are not needed. So I will test and show you these things. So now what we have to do is we have to go to the dist packages here, Python user local. You have to go to the other locations, computer. Okay, and from here where you have to go is you have to go to the user, it's over here, and to the local, and lib, and in lib you have Python 3.6 and 3.7. so it may be in any one of these things. Okay, so there should be something called .so. Okay, .so, so you have to search it. .so. Okay, there are lots of things over here. There are lots of .sos over here, but you have to find the specific one. I will tell you which one. Okay, so let's go down. So there is another tutorial which is given correctly. Okay, so you have to find this so-called CV2 or CV2 Python this thing. So you have to move this. So in order to move this, you just type this, no? So this will be over here. Okay, this is not available over here, not this one, not this one, this one. So this is actually .so of this type. Okay, so this is .so of different type. So we have to find that GNU. Actually, it is GNU.so. So you have to find it. It is really very hard to know that. So in here, it would be given as so cv2.so. I think this is the one, I guess, cv2.so, but not this one. It is supposed to be GNU cv2.so for cuda. Okay, so let's search for it. So just go here and then just type .so and enlarge this. So this is C Python integers, C Python G, C Python 3.6 .so. So these are all Numpy rand. Wait a minute. GNU.so, Opencv GNU.so. Okay, now I will tell you where to copy this. So this is so easy, you can copy it. So now what you have to do is, I will tell you this before. You just get over here and now you have a test for this to run whether Opencv is installed for this inside this or not. So you just type Python and you just import cv2. So it's not found over there because in cv there is nothing like that. So when you start to build in your Opencv, no, in this Opencv, no, you have a build folder you created, no. In that, where you have to go is you have to search for .so. Okay, and in .so what you have to do is you have to go to the last one, and there is a file called cv2.so, no. You have to copy this and you have to go to the home, and when you type this virtual environment, no, dot control h, you just type this, you have a cv folder. This is bin, this is library, and in the 3.6 in the site packages you just drop this. Okay, you just drop this, and now if you do, I guess it will show up. You can see now, you can see, no, import cv2. Now it is being there. So where did I drop this? In site packages in lib. Okay, in Python in virtual environments. Only this will only show up in this. Actually, this is in the home folder. Don't mistake with the another one, with the other locations computer. So when you go here, so I got this from the folder where I unzipped and I built it. So you go here and if you type .so, and in the last part you will have cv2 gnu Python. Okay, C Python.so. So this is compiled for cuda. Okay, so you are copying this, specific file. Okay, I will try to rename everything and I will get it and I will put it in a file so that you can understand. Okay, this is the specific file you have to get. Okay, this is the specific file you have to get, and you have to paste it on where? In the home. You have to go, you have to press Ctrl H, you have to go to the virtual environment, CV, library, 3.6, in the site packages, and you have to paste it over here. Okay, and after that if you import, it will be there. Now I will tell you whether it is installed for GPU or CPU. Let me show you that. Okay. Oh, wait. So what we have done, I will tell you. So in here, what we have done is, we have just copied this .so from the downloads. We have gone to this OpenCV, and in OpenCV there is a build folder. Okay, in build folder, you just type .so. You just type .so, and there will be many files over there, and you have to go to the last file. Okay, you have to go to the last file, and if you go to the last file, this is the file, and you have to copy this, and you have to come here, you have to press Ctrl H, and you go to the virtual environment, go to the CV, and go to the libraries, and go to the Python 3.6. Inside the site packages, you have to paste this, and after pasting it, what will happen is, when you just type this import CV2 count device enabled, you will see that 2 is returned, so that you have 2 GPUs. So this is how you install OpenCV OpenCV for CUDA. So thank you for this opportunity. So our friend gave. So thank you all. So this is how you install OpenCV for CUDA. So I will give you all the information regarding this. So thank you. So this is how you do. So I will copy this. Okay. Okay, that's it. It's finished. So this is how you install OpenCV for CUDA. Thank you. Okay. So, and after that, if you want to get into the environment, workon, you have to type workon CV, and you'll get into the environment, and you type Python, and you import CV2. Okay, and after importing CV2, you can check the CUDA count. Just type this. Okay, you just type this count, and I'll give you all these commands. Okay, and after that, what you have to do is, you have to type this count. So you can even inference up to 1000 cameras with this. Okay, so there is 2 CUDAs, so we have to not leave any gap. Okay, so there are 2 things. Okay, right, and if you go to the gedit vashrc, and in that, where these are all the virtual environments you have that supported these things, so you have to install all these things, and you have to give the specific version of Python 3.6 and everything. Okay, so take a very good look at it. Okay, take a very good look at it. So in here, what I have been given, I will show you. So in here, these are the things, export source and all those things you have to give it correctly. So I'll also give it in my thing, and after that you have to give source bash rc, and the virtual environment will not be visible. When I click this Control H, it will disappear. When I click again, it will come again, and you have to go to the CV2. You have to take this .so file from the OpenCV 4.2 build folder .so, that file, specific file, the specific file name. Okay, the specific file name, and you have to copy and paste it in the library site packages, so that it will be working. Okay, thank you for this opportunity. Thank you. So this is how you install CUDA, OpenCV in CUDA. Thank you all guys. Thank you. Okay.